Assalamualaikum and good morning. We are from Group 3 for case study discrete mathematics. Before we begin, I would like to introduce our team. If you can see first picture, we have Zarifa, our group leader. And next we have Amini. Then we have Amimi. Following Amimi, we have Inshira. And lastly, we have Aja. And let's begin with problem statement.
Hello everyone, today we are diving into the world of LAN network optimization with switches. Let's explore how we can make our networks super efficient. First up, we have the minimum spanning tree. MST is like our network's best friend, helping us connect switches in the smartest way possible. By minimizing data transmission and avoiding loops, MST reduces complexity and save us cost. Next, we have Kruskal's algorithm. These nifty tools help us find the MST in our network graph and ensure that all switches are linked with the fewest connection and no cycles, making our network setup super efficient. Our main goal in LAN optimization is to design a network layout with the lowest total link cost. We aim to connect all switches without creating loops, which boosts our network's efficiency and performance. When setting up LAN in office buildings, we install multiple switches to connect devices. Our aim here is to minimize cable length, cutting costs, and enhancing network performance. By optimizing our LAN layout, we save money and improve network efficiency. This optimization ensures smooth operation by reducing unnecessary data transmission and network congestion. In our network optimization strategy, we focus on connecting switches in the most efficient way possible. We emphasize simplicity, cost effectiveness, and ensure a smooth flow of data across the network. That's all for problem statement. Of describe the graph or three vertices and edges in the graph that we provided. The vertex represent the switches label A, B, C, D, and E. The edge or arc between the vertex indicate the connection between the switches and their associated weight. Each edge specifies the weight needed to traverse from one switch to another. By organizing the switches and their connection in this way, we can analyze and optimize the network structure efficiently. That's all for describe the graph or trees, vertices, and edges.
Here is an interface of Graph Online. To create a graph or tree to construct graph or tree, we have to click on Add Vertex, which is we have to begin by adding nodes for switches. We can type A, B, C, D, and E at Add Vertex. Next, to add edges between the nodes based on the weight provided in the table, we have to click on Connect Vertex button, which is we start with A to B, we put 10. A to C, we put 20. B to C, we put 30. B to D, we put 5. C to D, we put 15. And the second one is C to E, we put 6. And the last one is D to E, we put 8. After that, you can adjust the layout and style of the graph to make it more visually appealing. Once you have added all the nodes and edges, you can rearrange them to represent the connection accurately. Finally, you can save or export the graph for further reference by click on Graph and export the file. That's all for a demonstration of how the graph or tree is constructed.
So we continue to our last part, which is how to solve the problem. Imagine you have a graph with various cities and roads connecting them. You want to build the shortest network of road that connects all cities without any loops. This problem can be solved using critical algorithm, a method that efficiently finds the minimum span tree MST of a graph. Critical algorithm is creative algorithm used to find the minimum spanning tree MST of a graph. The MST is a subgraph that includes all vertices with the minimum possible total edges, weight, and no cycles. So I will show you guys how to create graph using critical algorithm with tools called Graph Online.